Space Agency's Astro Challenge is an annual science and coding competition where students like you have the opportunity to develop code that could be run on the International Space Station's Raspberry Pi computers called Astro Pis. Every year, youth from around the world participate in this challenge. This year, I was fortunate enough to partner up with youth from Toronto, Canada, who are mentored by Dr. Bhairavi Shankar. Let me introduce you to my team S1tauri and its members. Hi, my name is Yusuf Hussain. I'm 8 years old and a grade 3 student. I love coding games on different platforms, reading books, playing basketball, and participating in hackathons with my sister.
Hi, my name is Bobby. I'm in grade 5 and I'm super passionate about space technology and artificial intelligence. When I grow up, I'd like to become an aerospace engineer and an entrepreneur and create a company in the space industry. I've won many STEM challenges and have taught over 100 plus kids around the globe about STEM and space. I also really like programming in different languages like Python, HTML, and JavaScript. I was really excited when Bhairavi invited me to be in this challenge, and it was amazing working with my team to create this project.
Hi, I'm Shifa and I'm 14 years old. I'm currently serving as an ambassador for organizations that advocate women in STEM. I am an inventor and student innovator. I've participated in many hackathons across the globe and have received awards for my work. I aspire to merge the fields of astrophysics, medicine, and robotics as my future career. This is my second time participating in the Astro Challenge, and I'm grateful to have been invited to participate. This challenge was truly a wonderful experience with amazing team members.
Let me give you a little background on our project. This year's challenge allowed participants to select from two categories of one: life on Earth and life in space. Our team's goal was to investigate the potential rate of algae growth in lakes and rivers across areas the space station flies over. As you know, pollution is a huge problem these days, especially nutrient pollution. The excessive use of fertilizers in farming, discharge from sewage treatment plants, and stormwater runoff have a major impact on natural surroundings. Bodies of water suffer most as toxic waste from industries threaten both wild and aquatic life. It also promotes growth of harmful bacteria and non-native plants. Rising temperatures within water bodies from climate change has also led to growth of large algae blooms. Algae is an aquatic plant that includes seaweeds and many other single-celled forms. When algae die, they are decomposed by bacteria which can remove oxygen from the water, killing aquatic life. This organism can have an enormous negative impact on health, wildlife, and economy that depend on fishing and tourism. The results of our experiment will help us inform people living near these water bodies to help manage the bloom growth, reduce pollution activity, and keep the water safe.
Since we were only able to collect 3 gigabytes of data within 3 hours, it was crucial to use our time wisely. There were a few calculations that needed to be done, though. The number of sunsets the International Space Station sees in an orbit time of 1.30 hours is about 2, with an interval of 45 minutes. For the amount of time we wanted to run our code for, about 3 hours, we had about 6 sunsets with intervals of 135 minutes. Realistically, though, it was more likely that we would experience about 4 sunsets, so that was an important thing to keep in mind.
In our code, we have 4 sections. First, we have checking whether it is day or night. Second, we have taking our picture. Third, we are having to check the latitude and longitude. And fourth, we're transforming into NDVI. Our whole project is supposed to run for almost 3 hours, so we have a while loop. We first want to check whether our camera or International Space Station is in daylight or darkness, since it is in space. So if it is in daylight, it should proceed to do our program. Else, it should print in darkness, wait 10 seconds, and do the while loop again to check whether in day or night. So if it is in daylight, it should take our picture while it is daylight and then save it inside our images taken by camera folder. Then we have a special piece of code that checks the latitude and longitude of the taken image. And that latitude and longitude will be an EXIF data that's actually stored in the image, where we can check at any time. We're using the latitude and longitude to see what the location of our taken images are, and it will be very useful. Then we can find out where the algae blooms are.
Once the Pi camera detects daylight, it runs the image through the NDVI code. Let's take a look. The of the NDVI code is increasing the contrast to highlight all the details in the picture. So I added a new function called contrast to sketch. I added these two lines to the function to find the top brightness of the pixels in the image and the top 5% and bottom 5% of the image. The brightest of pixels color can be is 255 and the lowest is 0. Later on, the European Space Agency shared files with the image taken from Astro on the International Space Station. Since the image taken from the camera on the space station was pointed through a tunnel to capture the Earth, it was crucial for the images to be cropped or masked before converting to NDVI, as including the darkened portion would alter the results. I decided to approach this challenge in different ways. My first attempt was using masking to cover a specific area. However, an important thing was that the masking only fully encircled the Earth if the image was a specific size. The NDVI code was tested and worked perfectly. This project took 3 months to complete, but it was worth all the hard work. The trained model gave satisfying results, and we are confident that this will benefit the world. We hope that our project is selected for Phase 3 of the competition.
We had 2 experts to help us through this journey, and in different aspects so our program could be exactly how we wanted. Firstly, Dr. Karen Binding, who is a research scientist with Environment and Climate Change Canada. She studies lakes and how we can use satellites to learn about algae blooms. She helped us understand more about algae growing in lakes, and she talked about the growth of algae. She also clarified all of her questions about these unhealthy plant life. Dr. Binding talked about how satellites are very useful for studies about algae blooms. He was a huge help in our data standpoint. In our coding area, Mr. Sears, who's a PhD student at Queen's University, he helped us enhance our code and suggested cropping our images worked out really good. He helped us code our Skyfield program and find the right resources to use. He also covered up how to solve most of our errors and put our program together, and it worked out amazingly.